Hello. How y'all do now? Okay, so I figured out last night what I was doing that was wrong and dumb. Basically, what's going on here is that we need, so when we check the overflow, right? The way that this bug works is just that it increments by 5 instead of 4. I don't know why the description is so complicated on NES, but all that happens is that instead of incrementing the sprite index by 4, once you go into overflow mode, it increments by 5. So what we're going to do here is we're going to do read OAM. We're just going to use CPU.spriteIndex as usize. And that's all that should really need to happen. So when we add read OAM, which is right here, we're just going to set sprite index equals 0. And delete this. And then in test sprite, we're going to increment it by 4 somewhere. I'm not totally sure where yet. I guess right here, right? Because this is offset. But this is in secondary OAM. Wait. I'm pretty sure this is wrong anyway. Oh no, I guess this is right. Okay. I guess it's only in read OAM, right? We're just going to bump this every single time. CPU.spriteIndex plus equal 1. And that's easy enough. But then, once we get into test overflow, the other thing is that once this flag is set, we can just like be done because it's already set. So all we really need to do is delay until h blank, right? Which we will do in a moment. We are going to read all of these, but we're not going to come back to the check overflow state because we'll be done with it. And then this is all dumb. This can all go away because we'll be done. And then this is all dumb also. CPU.spriteIndex plus equal 5. This is the bug. Just get rid of all of this junk. If CPU.spriteIndex is greater than 63, then we're done. And then we're just going to do a read in OAM bugs, which again is going to use CPU.spriteIndex. And that should be all that is actually necessary to implement the sprite overflow bug. Except that I still have sprite n in a bunch of places and it's not useful. I don't even think I need this at all. So all this goes away. 348 is going to be as usize, of course. we do read OA unbugged, it should increment again. So I don't know why we got 33 3 times in a row. That doesn't seem right. Oh, it's because we hit this, obviously. That's why. I guess these don't actually matter. And then this is obviously wrong. Okay, so now we actually need to do this delay until H blank thing. So let's figure out how long that needs to take. I think we basically are just going to delay until a particular cycle, which looks like 257. So, yep, 257 is when we're going to do this junk. Ought to be relatively straightforward. But we still have to do this PPU warm-up thing. I got to do that at some point, but anyway. So, for I in cycle plus 1 dot dot 257. Or no, not cycle plus 1, cycle plus 6. I. And then we're doing push front. So we want to do sprite Q, push front, sprite state, sprite up. What's the next thing? Is like name table fetch, I guess. Right? Sprite up, fetch NT. Cycle is going to be 257. Scan line is going to be scan line. And then down here, we basically are going to do the same thing, I think. Do-do-do-do-do. Do-do. Do-do. Except that this loop should just be from cycle plus 1 now. What language is this? This is Rust. Also, welcome, GTX Gaming 23. So yeah, this is a Rust program. It is an NES emulator. The goal here is to complete it to the point that it is capable of running Super Mario Bros. 3 in less than 2 weeks. So far, things are going fairly well, I would say. There's been some issues, but not too bad, by and large. And then for now, sprite up, fetch NT, CPU, cycle, scan line is just gonna panic, because that's how we know that we made it to a place. Yep, and then we explode there, which is good. We do make it there. And if you look at the frame, so we fetch an NT byte but do nothing with it. We fetch an AT byte and do nothing with it. And then we start fetching sprite tiles. So this should be easy enough. Fetch NT, just do exactly the same thing, but then don't do anything with it. Doo-doo-doo. GTX Gaming 23, what brings you by? Did you just stumble across me on Twitch, or did you find me at one of the various social media places, or are you interested in emulators, or yeah, just saw you by on Twitch. That's awesome. I'm always really happy when people just sort of find me organically. Makes me feel like a real Twitch streamer. I like coding, but I don't know much. Well, feel free to ask any questions that you have, and I'll do my best to answer. Base plus tile. Thanks. Yeah, no problem. Okay, so 257, 256 divided by 8. You see tile 32. That makes sense to me. I wonder how the garbage name table byte even works. It doesn't really say anything about that in here. Garbage fetches occur. If there are less than 8 sprites, then dummy fetches to tile F occur for the leftover sprites. State is then discarded and loaded with a transparent set of values. Happens during the second garbage name table fetch with the attribute byte loaded during the first tick. Loaded from secondary OEM into their respective latches counters. Okay. Hello. Hi, Mr. Halsey. Welcome aboard. The tile data garbage name table byte. Okay, so I think I'm just going to fetch this at base, because it shouldn't really matter. Actually, how big is the name table? I mean, it doesn't matter. These are not going to be used. Let underscore equal to indicate that we're throwing it away. What brings you by today, Mr. Halsey? Are you a programming type? Are you interested in emulation? What caused you to stop in? I really appreciate you coming by. Okay, we fetch the name table. Doing some rating. That word is so overloaded now. Do you mean Twitch rating, or do you mean, oh, hello. You mean Twitch rating. Welcome, everyone. Thank you so much. Welcome to the stream, everybody. This is, my name is Andrew, and I'm working on an NES emulator. The goal is to complete it in less than 2 weeks, or less than or equal to 2 weeks, and make it to the point that it is able to run Super Mario Bros. 3, although without sound. Sound is optional. This is a challenge that was issued to me from the emulation Discord, and I decided that it sounded like fun, and I'm trying to do it in Rust. So, which I guess you guys know about Rust, because it sounds like Mr. Halsey is working on an MMO game in Rust, with Rust as a game server and Godot as a game client. That sounds really interesting. Is that something you have prior experience with? I remember several years back there was like this frustration on the gamedev.org about everybody trying to do MMOs, but I think you should absolutely do that if it's what's interesting to you. Alright, so we did fetch AT. Now we gotta get the low sprite tile byte. Fetch sprite tile byte low. That is also a 2-tick. Everyone does MMOs, emulators, compilers, operating systems, game engines, etc. Yeah, I mean, that's true. Because those are the cool things, right? I don't know why you would do something that was not interesting to you. Okay, so what actually happens when we fetch the low sprite tile byte? Pattern table tile low. Which I guess is just exactly the same as what was going on up here. Yeah, okay. Fetch BG low. Let's call it fetch sprite low for symmetry. Sprite out. Well, again, thanks for the raid, Mr. Halsey, and anybody who decided to come along for the ride. I appreciate you stopping by. I hope that you enjoy your stay. If you have any questions, let me know. I'll be happy to answer them. And yeah, thank you. Sprite pattern table address for 8x8 sprites. Background pattern table access. Okay, so the difference is that the sprite pattern table base is bit 4. Or bit 3, rather. So I already wrote this, just need to make it 3. Ignored in 8x16 mode. Actually, I should just do that because I've already got a get sprite height function. Okay, so let's just make this, what would that be, 5? And then we'll say 0B 1, 2, 3. So basically, if the sprite size bit is set, then we ignore this and just return 0. So this, or this is the only one that is 1. And then that should work. Okay. And you get, instead of fetching it from the name table, you fetch it from the sprite data, which is going to be around somewhere. Okay, byte 0 is the Y position, byte 1 is the tile index number. So, whoa, what the, what? Oh, Cortana. Okay, Cortana just popped up Edge for me, thanks. The only thing I can compile is good coffee. Hey, that is the most valuable skill of all, if you ask me, which you did not, which is unsurprising. Fetch sprite low. Alright, when we go into this whole thing, when we transition, actually, I mean, I guess we can just set it. No, we can't reset it there because we have to do it every time. So let's just do it right here. Yeah, that should be fine because it won't come back here because I've terminated that loop or that thread. So for those of you who are watching and have a little bit of familiarity, I'm doing something slightly odd here in terms of how I've implemented my engine for this. Instead of doing like a main loop in the traditional sense, what I have here is I have a queue of micro operations, which can then be used to, or actually I have 2 queues. I have one for background and one for sprites, which can then, we just sort of process the queue in order. The reason that I'm doing this is partly because I thought it sounded cool, partly because I want to eventually do an N64 emulator, and I think this is a good design for something that has a deeper pipeline than the 6502 does. And also partly because it works well with how the 6502 is implemented because it has a lot of internal micro operations that are reused over and over again. So that's basically how this is laid out. You can think of it as like coroutines kind of splayed out into a queue instead of being a first-class language feature. Although Rust does have coroutines, kind of, sort of, innately. And you can read an interesting blog post about that. One-day generators will be usable. Yeah. someday. Tile index number. For 8x8 sprites, this is the tile number of this pattern sprite within the pattern table. Yeah, we know that, okay. And then the tile is 8 long, I think. Pattern table memory map for 8x16 sprites equals 0 to 1f, which is 16, I guess. But yeah, so it's 8 bytes. Okay, so then we want to do let index equal ppu dot secondary OAM ppu dot sprite index as usize times 4 plus 1. So that'll get us the sprite index, and then we'll add that to the base instead of the name table byte, which actually that probably needs to be multiplied by 8 in the background as well. Just check and see whether I did that or not. Well, I don't know. Maybe it's already multiplied. Whatever. We'll leave it alone and see what happens. Okay, so we do that. Should be pretty easy. And then we do fetch sprite high. And this shouldn't be BG low byte. It should be sprite low byte. And then we need to modify this, obviously, to do the right thing here. Boop. This should be a 2, actually. Boop. Should be a 1. These should be sprite ops instead of background ops. Go. BG state does not have a field cycle on line 406. Oh, because I didn't change it up here. That makes sense. Yeah, one-day generators will be usable, but I find that kind of like confusing because aren't generators like one of the major underpinnings for async await, which is like everyone is super hyped about. So I don't really understand how generators can still be unstable when you stabilize the async await. I mean, I guess I understand how it can be. It just seems kind of dumb to do it that way. But hey, whatever, what do I know? The compiler special case is if the state machine generation won't let you get access to yield resume as a user. Right, which, like, I don't know. I would have done that differently, personally, but nobody asked me, nor should they have. Oops. Whoa, nope, stop. I'm very sensitive to complaining too much about, like, oh, I would have done this differently, because I know that the team is getting real sick of that, and that's completely reasonable. I didn't add sprite low byte. I don't have a get AT base? Yeah, I do. Maybe I don't. I thought I did. No, I just hard-coded it. Fair. For some historical Rust memes, don't make Ateron put up another 8-part blog post. What was his 8-part blog post about? I'm not that plugged into the scene, I guess. Personally, I don't think async functions should suspend immediately only at the first await. Yeah, you're talking about like lazy. I don't know, lazy versus not lazy. For when they start actually executing. I agree with that. I would prefer it be the other way. Sprite by low, by high. Oops, it's high byte, not. Arg versus return position infiltrate caused a bunch of drama. Yeah, I guess that's true. I always thought that was kind of dumb, personally. Is that not what that's called? Oh. Why did I call it pixel state, sprite state, G? They added arg position infiltrate onto the return position infiltrate without community consensus. Oh, is that why everybody was so mad? What? Expected background state? Why did you expect a background state? That's not right. Oh, because I didn't change the queue name. Okay. Dumb. Yeah, is that why everyone was mad? That makes a certain amount of sense. I was thinking of, whatchamacallit. Oops. I was thinking of the question mark operator, which had a huge amount of drama around it. But I didn't realize that there was an 8-part blog post about the other thing. Because it just seemed kind of obvious to me. But things that seem obvious to me are frequently not obvious to everyone else. And things that seem obvious to me are frequently bullshit. So cycle. Infiltrate outdid question mark. .await even outdid infiltrate drama. Yes, that is true. I am still unsatisfied with the conclusion of that, but oh well. Again, was not consulted, should not have been consulted. Don't really use await, or have not yet had a reason to use await. Am I an await macro type of person or at postfix? I do not like. I feel like the solution that was chosen was the most bad of the solutions, honestly. I would have preferred await as a bare keyword like it is in C#. I don't think that the, oh, but you have to use parentheses argument actually holds a lot of water for me. Ooh, latte, yummy. So I would have been happiest with that if it had been a macro with parentheses, like, okay, that's a little annoying, but, or a macro like with parentheses, that would have been a little annoying. Postfix.await with parentheses would have been fine. Postfix.await exclamation point with parentheses would have been fine. I feel like .await bare is the worst option because it doesn't look like, it looks like a field, and it's not a field. Like, I don't understand why they were like, your intuition might be subtly wrong, so let's make your intuition completely wrong instead. Alright, I guess. But again, like, who cares what I think? I'm just some schmuck. Part of it was with how question mark works. Yeah, but like, question mark is not, like, we didn't even have question mark 2 years ago. I don't know. I would have just done it differently. There's a lot of things I would have done differently, honestly. And every time I say them, people like get less and less on my team. I feel like I'm like, there's a lot of things in Rust that I don't like. People are like, yeah, there's a lot of things in Rust that I don't like. And I'm like, we should have a stable ABI. And they're like, wait, hang on. Whoa. I thought you were going to talk about the borrow checker or something. I'm like, no. Stable ABI. Static or dynamic linking, that actually works. And they're like, I'm not with this guy. I don't know what he's talking about. He's a crazy man. plus 8. But yeah, like Rust is so fanatically committed. It sounds like if this continues, Rust will be a bigger mess than C++. I don't think that's true. I think that I think that Rust will never be as big a mess as C++ because the people who are in charge of Rust, for lack of a better term, are very like dedicated folks who really know what they want the language to be and take their stewardship of the language very seriously. Which is part of the reason why it is the way that it is because everyone's so hardcore about wanting it to be the best language that the language can be. But I think that because of that focus, is greater than 32. Wait, is that right? Yeah. Oh, this should be plus equals 4, actually. I think that because of that focus, the language should have been designed in such a way that it de-emphasized backwards compatibility, right? Because the thing about C++ is that it's such a mess because you can't drop things, right? Trigraphs are an excellent example. There's no way you can drop trigraphs because you'll break backwards compatibility. So what I would have liked to see was a version of Rust where you were guaranteed that old code could be linked, right? Hence stable ABI. But that the actual language was permitted to evolve and, grow and change. I don't know. That's just how I feel about it. Accessing byte something from secondary OAM. It's going to be hang on a second. I guess it's going to be this. Yeah. And then we could have the addition things be like this is the breaking line between I don't really know what I'm trying to say. The as keyword is a mistake. It should be a constant, especially with regards to floats. I mean, that is a good example also because that makes a lot of sense now that we have const fun. But we didn't have const fun for a long time. So we needed an as keyword. But now that we have const functions, we can't drop as because Rust will never break syntactic backwards compatibility. But if the compatibility level was at the level of the ABI, then we could break syntactic compatibility because it'll compile down to the same junk at the end anyway. This is why I think that's a good design for a language. If I ever write a language, I will do that, and I'm sure I will run into all sorts of problems that I just am too unaware of to run into, like I just haven't done that, so I don't know what the problems are. Okay, that doesn't seem right. Oh, I'm multiplying by 4 and then I'm adding 4. I'm doing it twice. Okay, let's just add 1 and make this 8 because there are 8 sprites. Rust has only gone through a few iterations. Were you around when they changed iterators? No, I don't think so. I joined the community well after 1.0, certainly. Oops, we exploded. It shouldn't be greater than 8. It should be greater than 7. Or it should be greater than or equal to 8, let's say. Looks correct to me. What's the next thing? So we're here, high sprite tile byte. We have another wait mem. You always have a wait mem. They broke stuff almost weekly before 1.0. Yeah, that's what I heard, which, I mean, makes sense to me. First 2 tiles on next scan line. Does this mean we don't actually do anything with the sprites? What does sprite do? Background render pipeline initialization. Read the first byte in secondary OEM while the PPU fetches the first 2 background tiles for the next scan line. 8 sprites total, 8 cycles per sprite. Read the Y coordinate, read the X coordinate. Alright, let's assert that the cycle is, what should it be? It should be 319, I guess. And then we'll push wait mem, and we'll also, actually we'll just do wait for v blank. Or it's not actually v blank. I don't know what this is supposed to be. Wait for end of scan line, let's say. So for cycle +1 ... 341. I and then panic. But what we're supposed to do next is push this junk with, what's the first cycle called again? I guess no op, right? Sprite op, no op. Hey, so what is your goal to get running in 2 weeks? The goal to get running in 2 weeks is Super Mario Bros. 3 with no sound. That is what Sai challenged me to do. And that is what I shall achieve. Cool. Yep, so I got my CPU. Oh yeah, duh. I got my CPU written up to the point of executing all of the official opcodes. I didn't implement the unofficial opcodes. What? Oh, yeah, okay. Cycle 0. I didn't implement the unofficial opcodes. And then now I'm working on the PPU. This is the sprite rendering, or the sprite stuff. I'm not doing any rendering yet, but I will in a minute. Assertion failed, cycle equals 319. That doesn't seem good. Oh. Well, what is it? I sort of assumed you would tell me what it was, but okay. That's because I didn't do assert equal. Is that a thing that we have? Do many NES games use them? No, only like 4 that I'm aware of. 291, huh? I wonder why that would be. Yeah, so only like 4 use them that I'm aware of. There's a list on the NESDev wiki, which is why I stopped. The only main thing that I have to do once I have like graphics and stuff working, you know, once that trivial task is out of the way, then is to do the mapper, MMC3. Currently I have the NROM mapper. I'm trying to get Donkey Kong working because that's supposed to be the easiest one to get working. Alright, what's going on here? Wait, did you say 219? That's, or 291, okay. Okay, so 319 minus 291 is 28. That doesn't seem right. What did I goof up here? So when we do fetching sprite low on cycle, fetching sprite high on cycle, fetching sprite NT on cycle, fetching sprite AT on cycle. Let's see what we get. The PPU is simple. Its super is not. I mean, it kind of is, but it's also kind of not. Okay, so 257, 259, 261, 263. Oh, well, that's the problem. We go back to sprite low instead of back to sprite name table. Third. That was easy to figure out. Yeah. Fetch NT. Go, baby, go. Explicit panic. Awesome. Okay, good. All right, and now this should just kind of cycle around. Let me just assert scan line is equal to 0, which should fail, obviously. Should loop back around with scan line equals 1. Hooray! Okay. Cool beans. So that should be, I believe, the full pixel pipeline, right? Like we should basically be doing exactly this thing. The next thing to do, this is sort of curious, is it supposed to skip? Oh, well, we need to deal with the post-render lines, obviously. But, so this is a little bit odd. Is it supposed to skip the first cycle of the sprite stuff also, or just the background stuff? It doesn't seem like it would make sense for it to skip just the background stuff. So I'm guessing it skips the sprite as well, and this is just because it's every line. For 0 to 239, so -1 to 239, it does this. Okay, yeah, this looks pretty good. I gotta fill in all the post-render lines and the pre-render line. Gotta set the v-blank flag, which I think is what the game actually blocks on. Like, if I take out my assert, which I did, and I just run this, it should just run forever at this point. Oh, no, it doesn't, because I don't move on. Of course, that makes sense. 282. Oh, that's interesting. Shouldn't have hit that, but I probably am not resetting sprite count. Yeah, I'm not resetting sprite count, so let's go ahead and do that. PPU.sprite count equals 0. To do, this doesn't go here. Attempt to add with overflow, 179. Sprite index plus equal 1. Well, that's not good. That's not supposed to overflow. Alright, whatever. Do this in a minute. I gotta go and get more coffee and just kind of do a couple other things. I'll be right back. I don't know, a couple minutes at most. Alright, be right back. That sounds like an insane amount of like I have been reading a bunch of like business books about how to like organize your life and achieve your goals and blah blah blah. And one of the most common examples, for obvious reasons, is that you want to try to lose weight. And when they give those examples, it's always like, suppose you want to lose weight. A good way to do that is by eating 1,500 calories a day. And I'm like, I would literally die. When I don't exercise, I burn like 3,000 calories a day because I'm 6'6" and 200 pounds. Like, there's a lot of burning to do. Also, I'm back. Thank you all for sticking around. I expected to see that little number in the bottom there at like 5. So I had to get coffee and drug my cat. He has kitty asthma. It's the saddest thing. Sprite index equals 0, which should be fine because we should not ever come back here. And then this explodes. So what I'm going to do now is I'm going to get to the point where it does loop forever. Because it should. Oh, I didn't reset sprite count. I only reset sprite index. Get this to the point where it does loop forever, and then we'll go ahead and try to glue in some of this other stuff. 179. What is up with this? How am I supposed to get out of read OAM? Because I'm obviously adding way too many of those. Accessing byte 29 from secondary OAM. And then somehow I end up at read OAM forever. Which doesn't seem to make sense. Is clear OAM calling that for some reason? Huh. How did I get stuck in read OAM? I should probably be printing all of the opcodes I'm dispatching. Oh yeah, I could easily eat 3K a day and maintain my weight. Kind of messes with your appetite when the cafeteria meat has pink and green spots. Yes, that is true. Does that mean you're still in, like, high school, I guess? Dispatching, sprite, UOP, sprite, UOP. Freshman in college. Ah, okay. I guess we did have a cafeteria. I wouldn't have called it a cafeteria exactly. And we did, whatchamacallit, it was actually pretty good food overall. Most of it tastes fine, but the sketchy stuff kind of ruins it. Yeah, I could see that. Boy, this sure is a lot. I should have found some way to terminate sooner. I should just scrub. Doo-doo-doo. Okay, here we go. So, we do clear OAM a bunch, and then we do read OAM, and then I guess test sprite is the correct thing to do. So basically what's happening here is that we're not ever encountering a sprite and also not ever moving on. Which does make sense. Because I don't have a terminate condition in check sprite. Which I guess what we want for that, let's pull up our timing diagram. So we're gonna start doing sprite evaluations at cycle 257. So basically, else if cycle plus 8 equals 257, do exactly this. I can definitely collapse a bunch of this stuff, but never mind. Except instead of going to test sprite, we're going to go to fetch name table, I guess. All right. We're still attempting to add with overflow right here for some reason. So we do the OAM clear. We do the sprite evaluation. Maybe what we want isn't this. All right, so let's do this instead. If sprite index is greater than 255, which is sprite index oh, it probably doesn't help that sprite index is a U8. I should probably change that. When does it loop? I guess we do read first and then increment it. So if sprite index is equal to 0, and then in read OAM, we're going to just want this to be a wrapping add. PPU.sprite index.wrapping adds 1. And then we will do for I in cycle plus 1 dot 257, right? And then this one will be, oops, 257. And then we'll just add, we'll just wait because we're done at this point. So we'll wait mem I. We'll frag a bunch of this stuff. And that ought to work. I also want to check one thing. Sprite high. And just, this needs to go up here. Because you have to push the operations in reverse order because you're doing push front. I think that's the only one. Okay. Go. Oops. Needs a PPU in front of it. Go. That looks good. We're just gonna keep on chewing forever. Let me just assert that the scan line is less than, what should it be, 240? 240. In the no-op so that it will explode when it hits that point. Assert scan line less than 240. Go. So Breadfish, what are you studying in university? Computer science? How about we just kill that so that we don't have to look at all the scrolling prints? All right, dope. So now Is there an idle cycle at the beginning of these guys? I mean, I guess technically no. Computer engineering. Does that have more of like an EE side focus? Because if so, that's very cool. Speaking as a partially EE person. That sentence really got away from me there. Okay, so for the post-render lines for sprites, if scan line less than 240, do this business. Oops. Or 261. Assert scan line is less than 261. Else for I in 0 dot dot 341. Or no, for I in 1 cycle I. No sprites on these scan lines. Q.sprite Q.push front. Do this. Oops, too much. Cycle is going to be 0. Scan line is going to be scan line plus 1. Yeah, it's closer to the metal stuff like IC design and firmware. That's cool. I love firmware, although that's probably just because I haven't written it in a while. IC design I would have really liked to do. I've never really done any of that. I have done a lot of FPGA stuff in the last couple of years, but other than that, nothing. 90% of embedded is staring at data sheets. Absolutely true. Especially nowadays, most board design and stuff is just like gluing together ICs that do what you want. Occasionally, you have to do a little bit of actual design, but it's upsettingly rare. Okay, so that was easy enough for sprites because they don't do anything, and they're not very interesting. So now we got to look at BGs and do basically the same thing. Assert scan line less than 261. We'll just copy a lot of this junk. We do nothing. These all need to be regular queue and BG op. I should probably change this to like a background queue or something, but whatever. BG state, BG state. It's literally like, hey, this is what we kind of want out of this design. Okay, let's open up analog.com and start searching for the ICs that we want to throw on this board. Yup, except I hate analogs, so I never use them. But yeah, and then what you do once you find the ICs is you're like, okay, let's look up the example schematics or the dev board schematics, and then let's literally copy and paste them into Altium. And then let's just glue these little islands of functionality together. Which on the one hand is awesome, but on the other hand, is kind of lame, admittedly. Oh. Okay, so for I in I mean, I guess it doesn't matter. It's not doing anything. Tile is 0. Tile can be whatever it wants, doesn't matter. This doesn't matter. Oh yeah, my digital logic professor is already having us memorize the part numbers of old Texas Instruments logic gates. Yeah, the 74 series logic and ALVC and LVC and all the different families of like, is it CMOS? Is it LVC MOS? Is it TTL? Blah, blah, blah. All of that is basically worthless. No scan line, huh? Oh, it's because it's underscored. I mean, it's good to know that those things exist, but remembering which one is ALVC and which one is LVC is like utterly unimportant. Interesting. So we hit 155 before we hit 50. I feel like we should have hit them at the same time. Actually, I feel that we should have hit this one first. So am I not advancing the scan lines for background ops? That would be sort of annoying. No, I am. Advancing to next scan line. Wait a minute, hang on. BG op, no op. Okay, well, yeah, that's a problem. I don't think this is like even slightly correct, actually. It's like trying to learn the standard library by heart. It's pointless since it's so easy to just look things up instead. Yeah, absolutely. Like, okay, what's the difference between CMOS and TTL? That's important. That's a good thing to know. But beyond that, like, whatever. And honestly, even that'll come up so rarely. And it basically only comes up when you have like hot swap stuff, and you can just use a hot swap controller. Wow, 28 viewers. It's a good day for me. I guess it's Saturday or Sunday? Sunday. And it's relatively early, so the Eurozone is awake. But still, that's awesome. Welcome aboard, everyone. I appreciate you stopping by. I guess I just like stopped halfway through background because I needed to do sprite stuff. That was silly of me. Okay, so if tile is 44, what cycle does that make this? I probably should have done this by cycle, honestly. I forget where this goes. I have ink horiz right here. But 256 is like too many cycles, right? 256. Oops, that's the wrong. Because 256 should be 32 tiles. 32. Delay through H blank. Which is going to be what? 320 minus 256 divided by 8. It's 8 tiles. So 4 I in 0 dot dot, or no, in 32 dot dot 40. We're going to do nothing. Wait them. Tile I, this doesn't matter, that is correct. And then when we start up again, it's going to be tile, I guess 40. is going to be GPU Q push front BG state BG op fetch NT again. Tile is going to be 40. Scan line is still going to be scan line, which again doesn't need to happen. Oops. Ah. Dagnabbit Vim. Okay, there we go. That'll bounce me back to name tables, and then the name tables will do their thing and fetch more background bytes. And then what we need to do is when we're in name table, if tile is equal to, what would that be? So this is 40, 41, and then this should be 42. And what we're going to do is, instead of pushing fetch AT with the same tile, we're going to push fetch NT with the next tile. And then else if tile equals 43. We're going to push no op with tile 0 and scanline +1. And that ought to do it. What language is this in? Rust. Yes, that is correct. Hello, GLend2 and Sasluka. So this is an NES emulator in Rust. The goal is to complete it in less than 2 weeks, or 2 weeks or less, to the point that it is capable of running Super Mario Bros. 3 without sound being optional, basically. Okay, that means it still didn't quite work out the way that I had intended it to. Are you planning to do audio too? Just answered my question. So I am planning to do audio. I just don't have to do it on a timeline, which is nice. Did the NES give direct access to the display buffer? No, it has a tile-based renderer thingy, which is what I'm working on right now. And I have implemented most of this here diagram, cycle by cycle. One thing about these old consoles, including the NES, is that they were very particular about like cycle by cycle access, because everything was programmed in assembly for the most part. And if I don't have the correct, basically, oh, is that running too fast? Is that what the problem is? No, it shouldn't be. If I don't have the cycle by cycle timing correct, then games like the one that is sort of canonical is Battletoads will not run. They will just lock up. So what's happening here exactly? What? Is the background running out of UOPS at some point? What's going on here? What is Battletoads? Battletoads is a famous NES game. For some value of famous, I guess. Let's just panic right here. See if we ever hit that. Okay, we do. So that's good. Oh! Well, yeah, this is wrong. It's also very hard. Yes, it's very difficult. That is true as well. Oh, and then this should probably be tile 0, scan line 1. I don't think this should happen. And then fetch NT. Yes, it's very hard to emulate and it's very hard to play. Right, because it is supposed to just run. Oh, I bet I know. I bet BG low and BG high are outing too early. Yeah. Else, if tile is less than 32, do that. No, wait, this should be correct. Logically, wouldn't the for loop go before the PPU.Q? Yes, but because I'm doing push front instead of push back, it's you have to do it in reverse order. I could do push back if I was like super confident about what was already in the queue, but I don't want to do that, so I'm just doing push front. Okay. What's going on here? BG increase tile something, scan line something, tile scan line. And let's give this a couple of indents so we can find it. And let's get rid of some of these other ones. Print line. Oops, too many dots. Okay. Boom. Okay, so we do hit explicit panic, which we already knew. Let's get rid of that. Okay, we're somehow calling no op on scan line 1 over and over and over again, which is interesting. Scan line is becoming 0 again. I wonder if my no op is just unconditionally passing scan line 0. Yep, that's exactly what's happening. Okay. That looks cool. Looks better anyway. We do increment horizontal up to 41. All right. Let's open up some of the useful prints here. You know what? If I make this, so currently I'm hitting that assertion, which is good. If I make this 62, I should hit the other assertion later in that same cycle. Nope. You know what I'm gonna do here is I'm just gonna add a cycle count. Probably should have done this a while ago. Struct PPU. And this will let me print out what cycle I'm actually on and when things are dying and whatnot. Actually, that should probably be a usize, which is fine. We'll leave this commented, and we will say self.cycleCount plus equal 1, and we will say executing PPU cycle something self.cycleCount. Okay, and so this should help me figure out. Whoa, that's a lot of cycles. This is too big. I gotta shrink this. 70362 divided by 340. 206. That's not right. And as you can see, it's because we're getting BG no-ops like every 2 cycles, which is not what's supposed to happen. Right, so this looks correct. We hit increment horizontal every 8 or so cycles. We hit no-op every time we've gone all the way through, but then the don't do anything thing is what's causing a problem. So what's going on here? It's this bit that's not working. Let's make sure we hit it, which we almost certainly will. Doo-doo-doo. Kablam. Yep. Oh. That was dumb. That was very dumb. Okay, now we should hit the other one. Nope, still didn't. Cool. Let me just... Okay. This still doesn't seem right. Wow, 29 whole viewers. Thank you everyone for coming by. It really means a lot to me to see people stopping by, and hopefully you find this to be interesting. Despite the fact that I'm currently just kind of beating my head against the wall a little bit. Let's see, what do we got here? Man, that's a lot of stuff going on. You know what? I should probably just actually look at this in a text editor. Doo-doo-doo. Okay. PG no-op, sprite no-op. That looks correct. Sprite no-op. Okay, so the background no-op stuff is just ending slightly too soon. Let's restore the cycle count thing. And then let's make this less than 1 so that it dies sooner. $31, that's a new record for me. Okay, so this is cycle 293, which is obviously way short, somewhere in here. So am I not waiting long enough, or what's going on here? Okay, so we hit 32. It looks like we're not delaying long enough in here. Tile 40. Inc horiz. thanks everyone for coming by. I appreciate it. If you have any questions about what's going on, feel free to ask. I'm working on an NES emulator in Rust, trying to finish it in less than 2 days or 2 weeks. 2 days, 2 weeks or less, to the point that it can run Super Mario Bros. 3 without sound. If you want to just kind of chill and hang out, that's totally cool. I see the problem. 4, 5, 6, 7. So 1, 2, 3. And let's actually put these in here so that we can tell. Plus 6, plus 5, plus 4, plus 3, plus 2, plus 1. Okay, so we do need one more. That's exactly why we put that in there, so we can count correctly. There we go. Alright, I bet that fixes things. Go, go, go! CPU cycle 349. Also doesn't seem correct. Now we're 1 too slow. Which is interesting. This was cycle 0 up to cycle 340. So this should be cycle 341, but instead it's 349. Which I guess means this should be 39 instead of 40? What did I do wrong here? I'm sure this is just an off by 1 error. But times. See 312. But it's actually the 40th one, right? Times 8. Tile 1. I'm not totally sure what's going on there, to be perfectly honest, which is not great. I mean, I bet this change fixes it, but I don't really like not knowing why it was wrong in the first place. Okay, yes, that is what we wanted. Or no, hang on, that's fine. Assert. And change this to whatever it's supposed to be, 261, I think. 261. And then let's look at the next one, which is this one, and let's make this one less than 1, just to see that it explodes immediately afterward. Hey, there we go. That's synchronicity. Alright, 261. Go! Boom. And then to make it 262, should fail on the other one. Nope, that's not what happened. Cool, 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 cool. It looks like we stopped executing sprite operations at some point, which is not supposed to happen. Huh. What did I do wrong? Let's get rid of this CPU cycle thing for now. It'll be easier to see what's going on. Whoa, what? Okay, so we're getting sprite no-ops way slower than background no-ops again. Maybe that has to do with... I bet it's the background no-op lines that just skip everything I did wrong. really see how, though. BG no op, sprite no op, BG no op, sprite no op. These match up to a point. Whoop, there it is. Whoop, there it is. So sprite no op scanline 15 is correct. But then after that it stops. That's a weird place to just randomly die. Scanline 15. Oh, you know what? I bet scanline 15 is when we stop hitting this. Or, no, panic, not assert. I bet this is what happens, is that after scanline 15 is when we start hitting that, and that's implemented wrong somehow. Okay. So which one did we hit? 361. So we hit this one. So this is incorrect for some reason. Push all this junk, and then we hit test sprite. Again, which is where we are currently, right? Yeah. So we come back here. I guess we aren't, well, no, sprite index should be incrementing. So we should be going through, oh, hang on. Is that wrong? That seems wrong. Sprite evaluation. God, this is useless. Okay, yeah, so that's what's going on. It's because we aren't calling read OAM all those times. We need to reset sprite index ahead of time, I guess. Or plus equals 3? Is that what we want? Because we've already incremented it once. Attempt to add with overflow right here. This is probably not going to work, but let's see what happens. I'm pretty sure this is wrong, just for the record. Wow, 35 whole viewers. Thank you, everyone. I really appreciate that. Attempt to add with overflow at 364. That means we're way off the rails. Yep. Yeah, I didn't think that was gonna be correct. You know what? There's absolutely no reason not to just read this stupid thing and just not copy it anywhere. Right? Because what do? We alternate read and write, but if we just alternate read and wait, then it's just gonna be fine. So read OAM, read OAM. I bet this is what the hardware does anyway, because that's just like more hardware-y. Nope. probably what's happening is that we're never actually hitting, yeah, we're never hitting this. I'm not sure. Sprite index, right? So sprite index, probably what we should do is make it not a U8 anymore. If sprite index is greater than 63, is that what I wanted? Not sure it is, in fact. Because I don't think I multiply sprite index by 4. Do I? Oh yeah, I guess I do. For the secondary OAM stuff. I'm not using this thing very consistently, am I? Okay, here's what we're going to do. We're going to start using sprite index as an actual... Well, that kind of sucks too, because you need to read the OAM. I was calculating it based on the cycle before, but I didn't like that. Alright, whatever. Here's what we're going to do. We're just going to turn sprite index into a U16 solely so that we can tell if it's gone over the end. And then sprite index. So that's fine. That's fine. This is not really necessary anymore, but it should be fine. This needs to be is greater than 255. That's fine. That's fine. I guess this is fine because we're going to be fetching in secondary OAM? I don't think so. I think this should be also 255. And then that's fine. I guess all this is fine. Sort of confused, but alright. Give that a shot. Boom. The length is 256, but the index is 256. Well, we've still screwed up anyway. 287. Yeah, I mean, sure. What's happening here exactly? Oh boy. Not sure what's going on here. I'm having a hard time keeping track of my whole sprite index thing at this point. I should really give it a better name and kind of like make it a little bit cleaner here. Or at least trace kind of what happens to it. Okay, sprite index. Let's take this nice and slow. Right, got our notepad. Let's take some notes. Cleared to 0 at end of clear OAM. Cycle 63. Hello, Dax Quinn. Thank you for stopping by. How's your day going? Then the next thing that we do is we read, set to 1, or incremented to 1, at first read OAM, which is cycle 65. What is an NES emulator? So the NES emulator is basically a computer program that behaves like the hardware of the Nintendo Entertainment System. So I have a program that mimics the CPU, which is in this file here. It's got registers, it's got instruction ROM, all sorts of stuff that a CPU would have. And then in here I'm working on the PPU, which is the pixel processing unit, which is basically the graphics system, and we're working on emulating that right now. Does that make sense? X message, welcome aboard. Just started Rust, bought the Rust book on chapter 6, enums. Well, cool. I like Rust. Rust is fun. Okay, so then we go into test sprite. In test sprite, if hit, nothing happens. We call read OAM next. If greater than 255, break, basically. So we have 0, 1, 2, 3. And then it should be 4, 5, 6, 7. So this should happen. I don't understand why is this never being hit exactly? Does this need to come before the y-coordinate business? No, because we should get pushed into check overflow. And like that obviously does work, otherwise we wouldn't make it to scan line 15. This is going to be so dumb when I get it working. Let's just print it every cycle, huh? What am I looking at? Sprite index equals self.sprite index. Okie dokie. Alright, well, sprite index is getting bumped every 2 cycles, so that's not right. Alright, so this is scan line 14. Sprite no op, scan line 15. Alright, so we're at 0, 0, 0, 0, all the way through clear OAM. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Blah, 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 blah. Oh, and this guy's already off to scan line 16 at this point. What? That doesn't seem right. Maybe I'm not supposed to be reading 8. Because we have 256 bytes of RAM, or ROM, or whatever it is. But we only have, how long? This long. So 256 minus 64 gives you 192, which is only enough time to look at 192 bytes, obviously. So I think what I should be doing is, instead of doing all this junk, we should do this and do PPU.sprite index plus equals 3. because we want to bump it 3 to get the first byte of the next section. And do this. And then hopefully this will work. Nope, not quite. Well, it got close. Oh, okay, I see what happened here. This needs to be actually greater than, instead of 256, it's 252, I guess. It's not ideal, but whatever. Go, go, go. Kablam! Okay, so we hit the explicit panic now, and we did check. Zero to 252. Yeah, so that works. So we'll drop that, and then this should work. Whoa, the length is 32, the index is 1000 something. Okay. 502. We're not resetting sprite index, I guess. Okay. A new problem, which starts on scan line 240 for sprite ops. This is good, we're making progress. Which is, we get in here, and again, this is in the for loop. I thought I fixed this already. Alright, whatever. Maybe I only fixed it in background. Go, go, go! Hooray! Alright, all of our scan lines match. All of our cycle counts match. Awesome. I'm very happy with this. What time is it? Okay, I'm getting close to the end of my time for this morning. I am going to come back this afternoon a little bit, but I gotta help a relative move. I'm sure you all understand. Let's see, where are we exactly to see if we can get anything else useful done in the next 15 minutes or so. Okay, so we've got all of the visible scan lines going. We've got all of the invisible scan lines going. We're not setting the v-blank flag, which is a problem we should fix. And we're not clearing the v-blank flag, which is also obviously a problem that we should fix. Clear v-blank, sprite 0, and overflow. Alright, so let's do that. We can do those. That's easy enough. So in fetch nt for background. Doodly-doo. We do all this junk. I think the only change is we just do if scanline equals 261. I should really name all these constants. Clear v-blank, sprite 0, overflow. PPU.PPU control and equal not, what is it again? PPU registers. Okay. No, it's PPU status, not PPU control. Status. Also in Rust, this is an exclamation point for no good reason. All right. V-blank, sprite 0, sprite overflow. So we just need to and it with not, what is that? At E0? Yep. Okay. That was easy. And now we need to set this, which is in fetch name table. If it's 241, we will set it. Again, this is maybe not the best way to do this, but who cares? set v blank or equal, I think it's 80. Yep, v blank. What's happening with the PPU right now? So if you look at this, I have implemented everything that exists. I believe, anyway. The last little touch that I was just adding is set v blank and clear v blank in PPU status, and that ought to do it. I also, oh yeah, the other thing is I need to do the like reset line thing. So struct PPU initialize. It's going to be a bool. We'll move this up because it actually does exist. In here, where is that? It's before name table type. So it's going to be false. There's a thing in here about that. Okay, so there's an internal reset signal which clears PPU control, PPU mask, PPU scroll, PPU header, blah, 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 blah. The reset signal is set on reset and cleared at the end of v blank by the same signal that clears v blank, blah, blah, blah. Attempting to write to register while it is being cleared has no effect, which explains why writes are ignored after reset. Okay, so when we do set register, which I think is just like a call. Yep. If self.initialized, if not self.initialized, ignore write while in reset, return. Hey man, my school's hackathon is coming up and my interest is in systems programming, but the interests of my friends are in game dev and front-end stuff. Any ideas for a project that would merge those interests? I mean, honestly, emulation is a pretty good one. Game dev, it's not technically game dev, but it's close. As far as front-end stuff, I mean, I'm not 100% sure. Another thing that you could do is you could do like a client-server type game, something very simple. Don't go overboard. This is a big problem in hackathons is people are like, oh, I'm going to make some crazy thing. Make a super simple client-server game. You can write the client side. Your front-end people can, or you can write the server side. The front-end people can write the client in a web browser. And then your game dev friends can actually like design and implement the game. That's like a pretty good split. I was right in the middle of something. What was it? Oh yeah. The reset signal is cleared at the end of v blank. So, okay. By the same signal that clears v blank, sprite 0, and overflow flags. So, move out of reset if applicable. PPU.initialize equals true. I like the client server idea. +1 on client server game. Yeah, so for the only hackathon that I really seriously contributed to or participated in when I was in college, my roommate, who was an architecture major and an artist and also a musician, he and I made a game that was like asymmetric, where it was like an astronaut versus an alien. And so one person played the alien, the other person played the astronaut. And the alien could see in the dark and could like spawn little baby aliens, so you controlled it like an RTS. And then the astronaut had to find and kill the queen, and that controlled much more like Contra or something like that. It was really fun. I really enjoyed it. I liked that, like, depending on which side you were, you got a very different gameplay experience. Like one of them was mouse focused, the other one was keyboard focused. It was really fun. We had a good time. We won like a prize for best collaboration kind of a thing because my roommate wasn't a programmer and I think he was maybe the only person there who wasn't. But it was really fun. I enjoyed it a lot. So you could certainly do something along those lines or whatever else you wanted to do. That was just something that sounded appealing to us at the time. But hackathons are really fun. I kind of want to like do an overnight EmuDev hackathon, but I'm too old for that shit now. I have responsibilities, maybe over Christmas when I don't have responsibilities. All right, well, everyone, thank you so much for coming by. I'm going to call this good for today. Not for today, but for this morning, because I have to go and help a relative move, like I said. I'll be back, I don't know, let's see, it's, what, 1 o'clock now? I'll be back probably around like 4 or 5, if you are, or 4 or 5 Pacific daylight time, I guess, if you have some time to stop by. I really appreciate you coming by. I hope that this was interesting and informative, and hopefully I'll see you again later. So long.